Morning, Mike Marshall from Wirtgen. I recognize some faces. Anyway, we're talking about recycling RAP mainly through cold mix plant, and what we are looking to do is to build a base material. So the recycled material will be covered. It's not a final material, so will be covered by an asphalt, a microsurfacing, a chip seal, whatever is suitable relative to the job that we're doing and the location we're doing. Typical plant today is built to take the plant to the material and not the material to the plant. So that gives you the ability, particularly if you're working with millings, to put this on a job site being produced, recycle the millings and place them back into the pavement. Cuts down on all of your transport costs and the overall cost of the job. A plant generally consists of 2 material hoppers as minimum, so you can do blends of material or you can do 100% of material. Transfer conveyor with scales, so you're measuring accurately the amount of material that you're going to recycle at all times. An ability to add a powder or a filler, typically cement in North America. The ability to add a bituminous binder, whether it be emulsion or foamed asphalt. Mix it all together in a twin shaft pug mill, and then load off to a truck or stockpile. The systems are self-contained with their own motors. You can locate these plants today just about anywhere. They're self-contained. And the cabin where we put in our control systems. The process itself is we load our aggregates into the hoppers, whether it be 1 aggregate type or 2, which I'll show you some slides of as we go through. Transfer conveyor to the weigh cell, that's your flow of material. And then here, again, I'll show you some slides, but we have proportional gates. So if you're doing a 75-25% mix of different materials, you can proportion your mix to suit here. So what's becoming quite popular today is 75% RAP, 25% crushed concrete. And it gets rid of these materials and puts them back in as road base. Our binders will be, if it's cementitious, normally cement, pug mill, and load off to a truck. So that's your flow of materials through a plant. It's just a little video that shows you how to set up a plant.
Once the supports have been extended hydraulically at the touch of a button, the truck can be driven away from beneath the trailer. And this plank is where the approach ramp for loading will be made later on. The spacious cabin can also be moved into operating position instantly at the touch of a button. The machine setup is very easy and can be done by the operator alone. In the cabin, the main operating panel. A schematic process display shows current machine status at all times. All operating panels outside the cabin feature damage-proof closure. But now, back to the setup of the mixing plant. The slewing discharge belt is ready for operation. Now the approach ramp for the wheeled loader is made. And that's it. Now operations can begin. Arrival, setup, and start of operations really are a matter of just a few minutes. Mixing materials and projected binding agents are supplied by contractors. The driver of the wheeled loader uses a remote control to communicate with the plant control. He can start, stop, and also control functions such as the vibration of the grids. This hinged grid can be swung up by remote control, and it only allows aggregate fractions with a maximum size of 4.5 centimeters to reach the high-performance mixer. Larger chunks are thus reliably rejected. In the continuous pug mill, the necessary components are mixed homogeneously. At the end of the mixing process, high-quality cold mixture has been produced. A construction site in the former East Germany. This crusher is producing part of the material for this KMA 200. The mixing location is directly on the site, where a new road is being built. Here, the machine is using hydraulic binding agents to produce the base course for the new road. The base course mixture is being made from equal parts of milled and crushed material, plus cement as a binding agent. In daily operation, loading the machine from both sides and also connecting it to silos and tanks has proven to be very advantageous. Since the KMA 200 generates its own electric power.
The rest is some sales guff. But that's generally how you're going to set a plant up. But if you take your safety considerations on the previous presentation, you just have to be, there's a lot of moving things, that loader is back and forwards, you've got trucks coming in and out, so you have, that's the aspect. The actual plant itself is not the issue, it's the moving of the materials around it. So we'd start with our materials. We can, once we've set up the machine and the plant, and we can now determine what we're going to mix. So this was actually a roller compacted concrete job in Wisconsin, but it's an example of how you can do a mixture of two materials, so you can load from the left and the right. We've got aggregate and sand as the ingredients for our RCC project. These are the proportional gates at the bottom of each hopper. So now we've got a 45% aggregate, 55% sand blend. That could just equally be wrap and crushed concrete. And you can see is that now it's coming up the conveyor. You've got a very well defined proportion of materials, which is very important to maintain your percentage blend. So our common materials that we get involved with is 100% wrap is most common. Wrap plus concrete is getting more popular to use up stockpiles of concrete. All new aggregate, cement treated base, as that job we were looking at in East Germany, is popular. Canada is doing boatloads of cement treated base through these sort of plants. And roller compacted concrete. So common binders, we're going to start with whatever our base material is, millings or crushed concrete. Most popular today is cement because it's low cost, $100 or $120 a ton, wherever you are around the country. But more is not better when you're putting cement in. Emulsion is popular in thinner lifts where you can get the water out quickly. Foamed asphalt or foamed bitumen is probably the most popular binder across North America today in these plant mixes. And then a combination of cement emulsion and cement and foamed asphalt. There are your typical binders that will make you a bound base layer, which is not asphalt. And it's very important to understand it's not asphalt. This is a bound granular base. That's the best way you can describe it. It's not going to be black, it's not going to be sticky, and it's not going to look like something you're used to seeing. So when you do see it, there's no need to go to the toilet. Plants are designed to be flexible and set up particularly to accommodate the traffic as we're moving around the site. So for example, you'd be able to connect the water, this would be compaction water, from left to right. If you're using emulsion, you could bring in your emulsion tanker either right or left. Foamed asphalt, you can only connect on one side because this is all of the heated system. And that's the sort of compact area. So that's a setup around about 130 feet by 130 feet setup. So it's a very small area. This allows you to set up on the job site very easily. You set up here as your plant, cement silo, bitumen truck, whether it be AC or emulsion, water for compaction, and then your route would be your trucks coming in this way, loading and going out. And that's what it looks like in reality, but very small. But this movement here, compared to this movement here, are your focus for your safety. And also the logistics. It's no use having this guy going half a mile to bring wrap to feed this. So this has to be situated close proximity to the base materials we're going to use. This is one of Brian's sites. Nice site, very safe, trucks coming in. Our wrap source, very close. Bitumen, cement, plant. Millings, if we are taken directly from a job site, let's say, and we're going to take the millings directly to the plant and recycle the millings and put them back into this hole we've created, try and keep the mills running the same speed each day and get some regularity in the material they're producing. Try and use the same mills and always try and use a white mill. That's very important. But if you keep them at the same speed, the same condition with the teeth, you will get then regular gradation coming to the plant. And that will allow you, in most cases, just to use a screen to accommodate your wrap. So usually, if you're taking milling straight from the job, you've controlled your milling speed, you can get 95% through that screen going directly into the plant. Maybe you've got 5% oversize. But that's a 1-inch minus screen. Then we load directly into the plant. So we're controlling the gradation of the material we're going to recycle and mix. And that really is really very, very important. If we're going to have chunks in a mix, we can't pave them, and we'll have weak spots in the base, and we'll get failures. So controlling the actual sizing of the material is really very, very important. So we've loaded here. You can see our conveyor. We've loaded here. Cement, bitumen. Now we're loading directly in the truck, and so those millings were milled in the evening, recycled, and now they're going to a paver. So it's just one train from the interstate, recycle, pave back. Some jobs, if you're taking old wrap piles, so you can see we've got wrap piles from all around the country here, then you'll use an impact crusher to control your grading and your sizing again. This is a job in South America. Everything was pre-crushed, pre-screened, delivered to the mix plant, delivered to the trucks, then directly into a paving operation on the highway. Weather, it's quite a forgiving operation because if you're taking milling straight from the job, they're under control, they're reasonably dry because they haven't been exposed to too much atmosphere. If you take from stockpile, if you take from within the stockpile, it's generally been protected from weather extremes because it's contained in the stockpile. But as a rule, you want to be thinking for foamed asphalt, the material that you're going to recycle, temperature minimum 50 degrees. Emulsion, most manufacturers will tell you they want an ambient temperature of minimum 50 degrees. So they are different. One is material, one is ambient. They're looking for that to get the water out of the emulsion mix, to get a break, to get strength. Heavy rain, it's clear. But how do you define rain? That's always the problem. Heavy rain, avoid. When you do it wrong, that's what it looks like. So this is a project upstate New York in November. So the material was just too cold. When we we didn't do it, I took the picture. When the contractor added the binding agent, in this case it was foam, the foam had a poor distribution because material was just too cold. So we had just stringers, poor strengths, potholes the first trucks would go over it. So that is how not to do it. And they're the key things: temperature and time of year. And that's for the mixing. So these were mixed too cold. Just going back to the plant to describe how we would now control our mix. So we have a schematic here, which is actually showing you, I'm sure this is like your asphalt plants, with the lights on, green. Are your lights green or red? If the light's green, it's good. Things are happening. If you run out of, you run out of cement. If you run out of water, the machine will automatically shut down, the light will change. I've run out of water, so you're not making a bad batch. But the important thing is here, these three entry points are where you'll put in your mix design. So the lab will give you the design parameters for that mix. If it's 100% wrap, typically you'll be putting in 1% cement, 2.2, 2.5% foamed asphalt, or 3.3% emulsion, and then water for compaction. Water for compaction is a variable. That should be your only variable when you're operating the plant. These two items, binders, are fixed by the mix design, but your moisture that you're adding is for compaction. And that will vary relative to where you've taken the material from. If you've taken it from the outside of a stockpile, it's going to be drier than from the inside. So you may have to vary your moisture content a little. Maybe it's 0.25%, that's all. You don't want this wet and running out the tailgate. But that should be your only variation in input values when you're manufacturing material. And this you would put in, if you're loading directly to trucks, then say you put in 20 tons. Plant will make 20 tons into the truck, then it'll stop. The loader operator keeps loading, next truck comes in, he operates a remote control, it starts again, makes another 20 tons. So you're always making the same mix of material unless someone educated tells you to change your binder content. Paving thickness, excuse me. This is a light, fluffy material. So we always recommend that you do a test section on how thick you're going to pave and how you're going to compact it to get back to your finished grade that you want. So I think your job, Brian, we actually paved 8 inches of material of 100% recycled wrap to compact back to 6 inches. So this is really, it's not like asphalt. While it's moist, it looks like asphalt. As soon as it dries, it doesn't look like asphalt. So it's got a high void content. We need to figure out on a test strip our paving. NCAT, US 280. NCAT invited us down end of, where are we now, 17? End of 15, to do some test sections for them on US 80. Cold in place recycling with foamed asphalt, cold and place recycling with emulsion, plant mix with emulsion, and plant mix with foamed asphalt. So this was one of the cold mix sections we did for NCAT on a live road, US 280. We got a cone. Sorry, we only got one cone, Mr. Safety Man. And we're running traffic there. So we got live traffic running alongside us. We pre-mill, and we have taken round about 5 inches off to pave back 4. So then we'll come back an inch lower than the adjacent carriageway, so when we put our overlay on, we're flush with the carriageway. So that's our project. Millings. We had a stockpile of pre-screened millings, 3/4 minus, so it's a very nice regular stockpile for this test section. We set the plant up as we've previously talked about. Our truck routes, it was pretty nice open site, it's very easy. Because this is just a small test section, I can't even remember how long. It might have been 500-600 feet. It was hardly anything. We didn't use a cement silo. We just used a little hopper here. Some people that NCAT didn't like, who filled it with bags of cement. So we did that manually, just because it was a small job. So our mix, we're now working in 20-ton batches. We've put in 1.5% cement, 2% water for compaction, and 2.5%, that would have been foamed asphalt section. The emulsion was 3.3. So we're 1.5, so you'll see a little fluctuation. These things are always hunting, but nominal 1.5% cement, 2% compaction water, that's your symbol, 2.5% bitumen, that was foamed asphalt. So that is your deal, don't change it. Load into trucks, you can see here, even while it's moist, it's not looking like asphalt. And then this is the critical bit. So you've set the plant up, you're happy, you've got all the values, you're making something, then all these guys come out of woodwork. Normally they're wearing white hats, but they all come out of woodwork and say, right, okay, now you've done this all wrong. We've got to change this. This is not asphalt. What you're producing is not asphalt. Up the AC, up the emulsion. No. It is not asphalt. Just tell them no. So when all of these guys come tell you it's wrong, just say, no, go away. I put my mix in. This is what the labs told me. The only people who are allowed to change the mix of the lab or the RE, all I can do, Mr. Expert, is up and down my water a little bit for compaction. So these guys are tourists, in my mind. So we take that 20-ton truck, deliver it into, this is a straightforward strike-off screed on this paver. So we're going to be paving thick and compacting down. So we're getting very little pre-compaction at a screed. And that's relative to going back to our test section. What screed are we using? If we've got a high compaction screed and we're getting 93, 96% compaction at the screed, we're probably only going to be paving 4.5 inches to get back to 4. If we've got a strike-off screed like this, we're probably going to be paving 6 to get back to 4. So do your test section. It's very important relative to the paver that's going to be used on the contract. This is your flow of recycled materials. It's 100% wrap, 3/4 inch screened, 2.5% foamed asphalt, and 1.5% cement. That is what it looks like. Now we're paving it. It still looks asphalty because it's moist. As you compact it and you squeeze in a bit of moisture, it starts to look a little bit more asphalty, but it's moist. That's not asphalt, you see, that's moisture. So this will dry back gray. So it'll look gray. So when everybody says, your road's no good, it's gone grey, just tell them it's okay. That's the way it should be. But you see, you've got a really nice tight mat here under compaction. This is what you want to achieve. Particularly if you're only putting an inch on top, this is where you've got to get your ride. So the better that material is, the better it's paved, the less asphalt, sorry Trenton, the less asphalt you have to put on top to get ride. But it's nice. You've got an odd couple of pieces here that have just dried during mixing or transport, but you can see it's not coated. So it's not asphalt, it's not coated. After we paved, we put on a light fog seal, diluted emulsion, just to protect the surface, because it's, if you go back to here, see these odd stones here? When you put traffic on this, you might get some raveling. So the fog seal has a dual purpose of protecting you from weather, but also raveling. Because we're now going to put traffic on this. As soon as this fog is ready, we'll put traffic on this section. So the recycle lane, you have to think, after compaction, I can put my traffic on. This is one of Brian's jobs. This was screen wrap, 1 inch minus, 2.2% foamed asphalt, 1% cement, 2% compaction water. Similar deal, we used a regular strike-off screed. So here we're paving at 8 inches to get back to 6 after compaction. I usually work on roller size, a ton of centimeters, so 6 inches is 15 centimeters, so you want 14, 15 ton roller. That's as a rule of thumb to get you good compaction with your recycled material. If you control your moisture, which you can do really well at the plant, there's no reason why you should not get really good compaction. I think you experienced that, Brian, yeah? And again, it looks really, this is asphalt now, you're saying, but that's how it dries. That's very good. That's also very good. Don't worry about it. And that was your section. I don't think we put traffic on this, Brian, but this was ready for the asphalt overlay, 2 inches.